Let's talk about a huge cosmic puzzle. How could the early universe be a raging inferno, just an infinite firestorm of light, but at the same time be completely and utterly dark? We're going to dive into the story of the universe's first 380,000 years, a long, slow dawn that finally let the light break free.
So get this. For the first 380,000 years of its existence, the universe was a total paradox. It was blindingly bright, packed with light, but you couldn't see a single thing. It was basically like being stuck inside a star. So what was going on? And what was the big event that finally flipped the cosmic light switch and made everything clear?
Well, in those early moments, the universe was what scientists call a cosmic soup. Just imagine this super hot, unbelievably dense plasma of particles. Now, in this chaotic mess, little packets of light, photons, couldn't travel anywhere. They'd take off and bam, immediately slam into a free-roaming electron, careening off in a random direction. It was like a game of cosmic pinball that never ended, and the light was trapped.
And when we say super hot, we are not kidding. The temperature of this cosmic soup was a blistering 11.6 million Kelvin. I mean, that's just impossibly hot. So hot that nothing stable, like an atom, could even dream of existing. It was all just a jumbled mess of particles getting torn apart by the heat over and over again.
So it's pretty clear the universe had to cool down a lot. But this wasn't something that happened overnight. Before anything interesting could really begin, the universe had to go through a very, very long wait.
And this timeline really puts that long wait into perspective, right? After one day, it's still just a raging plasma. After a whole month, you guessed it, still a plasma. Basically, nothing has changed. It takes more than 12 years just for the last unstable bits and pieces to settle down. And you have to wait 100,000 years before matter even starts to have more gravitational influence than all that radiation. The universe was just expanding and cooling incredibly slowly.
Yeah, there's a quote from our source that just sums this up perfectly. Even though the universe was this massive firestorm, for a huge stretch of its early life, not much was actually going on. It was just expanding, cooling, and waiting. So why? Why was it so hard for anything to change? Why couldn't atoms just get together and form? Well, it turns out it all came down to the basic rules of physics. You know, the rules of attraction and repulsion.
And that rulebook has a name you might have heard of: quantum electrodynamics, or QED for short. It's the fundamental theory that explains how light and matter interact with each other. And back then, QED was the reason atom building was pretty much impossible.
Okay, so here's the core of the problem. To build an atom, you need a positively charged nucleus to grab onto a negatively charged electron. But look at the scales we're talking about here. The nuclei were unbelievably tiny, just a few femtometers wide. Meanwhile, the electrons were just zipping around way too fast, spread out over a massive area in comparison. It's like trying to catch a speeding bullet with a pair of microscopic tweezers. It's just not going to happen. And QED actually gives us a very specific cosmic speed limit for this. For a nucleus to have any chance of capturing an electron, that electron had to slow down to less than 1/137th the speed of light. That special number is called the fine structure constant, and it basically sets the strength for this kind of interaction. If an electron was moving any faster, it had way too much energy and would just fly right on by.
So let's just recap how stubborn this problem really was. 1. The electrons are just way too fast and energetic. 2. Because of that speed, the space they take up, their quantum wavelength, is hundreds of thousands of times bigger than the tiny nucleus they're supposed to orbit. And 3. Even on the off chance an atom did manage to form, there were still these super-powered photons flying around that would just blast it apart instantly. The odds were completely stacked against it.
But after hundreds of thousands of years of the universe just expanding and cooling, the conditions were finally starting to get right. The stage was finally set for one of the biggest transformations in cosmic history, the building of the very first atoms. This whole process is called recombination. And as the universe dropped below certain key temperatures, things started to click into place. First, once it got below 16,000 Kelvin, helium nuclei could finally grab their first electron. Then, as it cooled even more, below 7,000 Kelvin, they could snag a second one, becoming stable helium atoms. And then, the big one. Below 4,000 Kelvin, protons, which are just hydrogen nuclei, could finally capture an electron, forming stable hydrogen for the very first time. And this right here, this gives you a snapshot of what the universe was made of at that moment. As you can see, it was overwhelmingly hydrogen,
about 92%, and helium, making up most of the rest. These simple, basic elements were now locked into stable atoms, ready to become the raw material for every star, every planet, and every galaxy that would ever exist.
So the atoms are forming. The loose electrons are getting captured and locked into place. That cosmic pinball game that was trapping all the light was finally about to end. It was time for the grand finale.
And it all comes down to this one number, 3,000 Kelvin. This was the final critical temperature, the tipping point. The universe was right on the edge of its most dramatic change yet.
But here's something that might surprise you. For the universe to clear up, not every single atom had to be formed. All that needed to happen was for the number of those free-roaming, light-scattering electrons to drop below a certain point. And you can see here, out of millions and millions of protons, only a tiny fraction, just 578 were still free. Those last few particles were the final remnants of the cosmic fog.
And then, it happens. The universe cools just enough, and those last few free electrons are finally captured by protons. And just like that, their density is so low that they aren't an obstacle for light anymore. The cosmic pinball machine was finally, officially switched off. And this is the moment. For the first time in 380,000 years, there was nothing in the way. Light could finally travel in a straight line, unimpeded. All those photons that have been trapped since the beginning of time were set free, streaming out across the cosmos in every direction.
And you know what? That ancient light is still traveling through space today. We actually see it all around us as the cosmic microwave background. It's like a fossil, a snapshot of the exact moment the universe lit up. It's the ultimate baby picture of our cosmos. And it leaves us with a huge question. What other secrets about where we came from are still hidden in that ancient light?